Hello again, this is UML Operator. All right, in this session, we're going to talk about multiple modelers working across multiple packages within the same project instance. So our first modeler, UML Operator in this case, and the chief architect, is building out their architecture that's going to be targeted for a particular program increment, in this case, PI1, and we'll continue to work this effort with the team throughout its delivery. Our next two modelers start to join in and start building out their model packages using UML Operator space. Modeler 1 locks their model so that the other two modelers can't work on the diagram, only locks the model for themselves, and the other, as you can see by the red exclamation mark, are unable to work in it. However, they can see who has the model locked and are able to collaborate with them if they need to access a diagram. Now we get to engineer 1's work, who is Eddie, who is going to clone UMLO's model for PI1 to extend for his PI2 architecture contribution. You can see that UMLO is still working his architecture while Eddie will start his first version. Note that Eddie's package will not include UMLO's elements and only include the elements he adds to his package. This modeler is now free to build their architecture while using UMLO's architecture as they work together. While the first modeler is working on their architecture, the second modeler is producing their work. Both modelers at the same time are adding intelligence, drawing associations, and collaborating together in real time. They're doing this while modelers are locking others out in order to protect the integrity of their work, their models, as they work, and that work will later come together as a whole. Now we get to the third modeler. They will refresh their project to see what others have done or are doing while they all work together. Modeler 2 now sees that program increment 2 is the structure that they wish to extend. Modeler 3, Tony in this case, will clone Modeler 2's package for their starting structure. In picking up this structure, they get all the work that Modeler 2 has done to this point. Note that I said to this point. Any models that Modeler 2 adds after the cloning of the structure will not show in Modeler 3's work. Let's get back to Modeler 2. They can lock their models while they work safely, guarding their model integrity, and while others are working from each other's structures. The third modeler can come in and extend the second modeler's work even though that modeler's package is locked. The third modeler simply clones the structure of Modeler 2's package so that they can do their e-commerce work for program increment 3. This modeler draws an association to the first modeler's service exchange, then the third modeler locks their package while they continue to work. Each of the modelers are adding intelligence to their model elements in real time, and each modeler can see the content added across models as they collaborate together. It's important at this time each modeler locks their elements so that others cannot add or edit content until they're ready to share. The first modeler, while working, needs to refresh their main package or project in order to see what the other modelers have contributed to this point. The chief architect, Modeler 1 in this case, asked the other modelers to rename their package from version number to program increment number. Again, this is all happening in real time through collaboration regardless of locations. Now Modeler 1 is ready to register their work in RAS. They will log into RAS, select the proper storage area, and while on the browser package they want to register, they will select Register button. From here, they will leave Check Dependencies Default, set the version number, comments, and descriptions of the registration event under Notes. Now we will verify as to what has been registered in RAS. Next, Modeler 2 wants to register their work in the same RAS instance. They first do a project refresh just to check for updates. They're on the package they want to register. They go to the proper storage folder. They see that UMLO has already registered their package, but RAS set it to 1.0 instead of 0.1. They version 0.1, add comments and description, then select Register to complete. Modeler 3 will register their package in RAS. They access the RAS instance, go to the proper storage folder, and while on the package they want to register, key in the necessary information and select Register. They confirm the package they are dependent on, validate they are getting the latest version, and they're now registered in RAS. They validate their work is now in RAS. All modelers will unlock their model packages as they are done with this iteration at this time. The chief architect can use security locks feature to unlock all models as they go through the approval process. The chief architect or any modeler will now create an end state view, which is a culmination of the 3 packages at this time. They can bring in each at a time or simply pick the latest package, which is PI3, and copy paste into the end state diagram. Now we have the latest elements and GUIDs for our roadmap architecture. Let's next version this diagram in RAS. Just as with the other packages, we'll register the end state package in the proper storage folder. It's important to check dependencies and ensure the latest version is included. We will then validate the end state as properly loaded. Let's now import end state into a separate Sparks project. This may be specifically for governance, security, or another group. If you only import the end state, you'll get dash boundaries. We must import the dependent packages to ensure that we're getting the dependent GUID elements. If we bring in PI1, it has the dependencies for PI2 and PI3, so we get all the necessary packages and elements. Next, we will add another package for the 4th program increment in this project. This will include all the architecture we have done to this point. We will clone the structure of PI3, which will give us all the elements we need. Each diagram has its own GUIDs, so it is unique to the other diagrams. The modeler will add the architecture for his program increment and model the necessary associations. The modeler will then clean up the diagram and prepare it for its presentation and collaboration with other modelers and stakeholders across projects. All authorized modelers can work in each other's packages. They should lock the elements they're working on and collaborate or chat with a model owner as to what they're doing. Here we see 2 modelers working on the same diagram and one element is locked. The modeler can open a chat session with the modeler that has the element locked and work in tandem to complete their work. Now the modeler, UMLO Chief Architect, is ready to register PI4 into RAS. They first may wish to update end state view before doing so. They follow the same registration process for their package, provide the proper version, comments, and description content. They ensure to check dependencies as they register their package in RAS. Then they validate their model content has been registered and is ready for reuse. Next, the modeler registers the new version of end state. They follow the same practice for registration. Now end state has a new version and is ready for other project instances. Let's now build a cover page for our project so that others can quickly access the models they need. This is done by simply dragging package elements into our blank cover page diagram. Because we cloned these packages, we see the trace dependencies included by Sparks. As we bring in packages, we simply drag and drop and can organize later. So with all our packages in our cover page diagram, we can organize elements before bringing the end state navigation cell. Now others can quickly access the diagrams from the cover page. Finally, we want to set the cover page as the default diagram to load when other users load the project. We close by locking the diagram from other changes. With RAS, authorized stakeholders can access and view assets in the repository. They can see and access all versions of these assets and reuse any version they wish. If they want to see where an asset was at any time during the program increment, they can choose that version, see and add reviews, and import into their own project. Note that GUIDs are maintained so any imports will step on or overwrite previous versions in their targeted project. You may wish to have a naming convention for versions, such as PI and a number or version and a number together, to understand the assets they will be reusing. In this session, we saw 3 architects working together to contribute to the overall target roadmap architecture. The first architect built out, double click on this, built out their 3 components. The second architect came in, extended those 3 components by cloning their structure into their diagram or model view, adding their architecture to the overall view, which is considered to be program increment 2. The third architect or engineer came in, cloned the architect for PI2 because it included PI1, cloned the structure, brought it in, and added in their architecture. All along, the 3 architects were versioning their architecture in the Reusable Asset Service, RAS. So they came in and they did PI1 to 3, and then they created an end state view version 01. So we can look at 01, we can go to content, and it included the first 3 program increment and their architecture in there. Then we saw the first architect working in tandem with the other 2 architects to build out PI4, which included the 3 components added for this particular program increment. And then the architect created a new end state version in Reusable Asset Service to be consumed. That architecture was then registered in the Reusable Asset Service. The end state was updated to version 02, and you can go to any versions I state in there, and the overall roadmap architecture is now complete. If this video was too fast for you, you can view the longer version, which is almost an hour long. Here we covered a scenario where 3 modelers are working together in real time while locking their work and collaborating. Whether 2, 3, or more modelers are simultaneously modeling, as long as you're following good practices, there should be no problems. I hope this session was helpful for you. I've been getting a lot of questions on using Reusable Asset Service with multiple modelers simultaneously working together and ensuring the integrity of their models across program increments and projects. Please leave comments down below, good or bad. I look forward to reading them, and I will see you in the next session. Until then, happy modeling.